Welcome to Brain Vision.
So in this question, we are told that a picture window has a particular dimension, which is an area of, let's say, 1.40 meters by 2.50. And it's basically made of glass, which is 5.20 millimeters thick. Now, the outside temperature, which is the temperature in which this glass is exposed to, is negative 20 degrees. And while the inside is 19.5 degrees Celsius. Now, our question says what rate of heat is being lost through the window by conduction? All right. So in this first set of the question, we are just going to calculate the heat current. The heat current when the glass is exposed to these different temperature regions, different temperature regions. All right. Okay. So at this point, what are we going to do? We're just going to take note of our temperatures. So we have, let's first and foremost look at the area. The area A is equal to 140 by 2.5, which is about 3.5 meters squared. Now the thickness, okay, in other words, the length, let me use the length in this situation. The length is 5.20. Since I've been using length, let me use the length. 5.20 millimeters. I beg your pardon, millimeters. All right, so when we convert to meters, about 5.20 times 10 to the power negative 3 meters. All right, now the cold side of the temperature is negative 20 degrees Celsius. And then the hot side of it is 19.5 degrees Celsius. All right, so the thermal conductivity for glass is also given as 0.8 watts per meter. That's Kelvin. Now, we shouldn't be so much confused about picking up some of these values because these are constants that we can get from textbooks or we can reference from the internet. All right, so picking our heat current equation, we have HKA into bracket the change in temperatures, TH minus TC, all divided by the length of the rod. Okay, all right. This is equal to the 0.8, which is the thermal conductivity, times the area 3.5 into bracket 19.5 minus 20. Remember, the temperature is negative 20 degrees. Minus 20. All right. And all of this divided by the length, 0.0052. All right. So when we do this should give us about 2.1269 times 10 to the power 4. So this should be approximately, let's break it down a bit, 2.12 times 10 to the power 4 watts. All right, so this is what we need to. Now, the B part of the question says that this glass was covered with paper, and then the thickness of this paper, let's say P, is equal to 0.75 millimeters. All right, 0.05. So it says that we should calculate at what rate would heat be lost through the window if we have it covered with this paper of 0.75 millimeters thickness. All right. Now the temperature of this paper exposed is 19.5 degrees Celsius, and then the other side exposed to the cold region is negative 20.0 degrees Celsius. And then the thermal conductivity, K, is equal to 0.8 watts per meter per Kelvin. All right, so picking our equation, H equals K times A into bracket TH minus TC, all divided by the length. This should give us about 0.8 times 3.5, 19.5 minus 20, all this divided by 0.0052. All right. So when you do this, oh, I beg your pardon. I'm repeating the same process. Forgive me. I beg your pardon. I'm repeating what we already did. I picked the wrong values for what we already did. Okay. So in this situation, since this time around is between the paper and the glass, we need to know that the heat current between the paper and the glass should be the same at the point where they're in contact. So therefore, we can talk about the same temperature at the point where they are joined together. So since we've already calculated that for glass, we need to know that we can still use that, but the reason being that we need to take into consideration the the temperature at the point where they are joined together. So that of paper, Ka into bracket Th minus T divided by L is equal to K of S times A to bracket T minus Tc. All right, and also divided by the L, which is the thickness. Okay, so we have 0.05 times 3.5 to bracket 19.5 minus T, all divided by the thickness, 0.00075 is equal to 0.8 times 3.5. Remember the areas are the same minus T, into bracket, sorry, T minus 20. All right. So what we're doing basically is that finding the thermal equilibrium or the temperature at the point where the two materials are joined together. So this divided by 0.0052, which is the thickness of the glass. I wrote this is subscript G. Subscript G. All right. Good. Let's move on with this. So we have 3.41 minus 0.175 T divided by 0.00075 is equal to 2.8 T plus 56 divided by 0.0052. Okay, so all that we are doing is to find the same temperature at the point where they are joined together. So this will give us 4546.7 minus 233.33 T is equal to 538. Let me rewrite this. Minus 538.5 T plus 10769.2. All right, so when we group them, we have 546.7 minus 233.33. Sorry. Minus 10769.2 is equal to 538.5 T plus 233.33 T. All right. So this is it. So we have negative 6222.5 is equal to 771.83 T. So the temperature at that point when they are joined together is negative 8.06. But we are not done right there because that's not what the question is asking us to do. So once we have this, what the question is requiring us to do is that how much heat is lost per second when we attach the paper to the glass. And that is what we are so much interested in. But before we get there, we need to also find that temperature, that equilibrium temperature at the point where the two materials come into contact. Hence, we need to find that temperature. So we have our HP, the heat loss per second by the paper is equal to K subscript P A into bracket the TH, or let me say the new temperature, okay, let's go with TH minus T, okay, that's fair enough, divided by LP. All right. Okay, so we have our HP being equal to 0.05 multiplied by 3.5 to bracket. Now the temperature difference should give us 27.6. As we find the temperature difference, that should give us 27.6. All right. So all this divided by 0.00075. And when you calculate, that should give us 6.4 times 10 to the power 3 watts. Okay. Don't be so confused about how we have this. Okay. Don't be so confused about how we have this. We have the 19, we have our 19.5 minus 8.06. And that is how come we have this. All right. So this is what we get.